Okay, so here we're going to talk about Avogadro's law. If you remember Avogadro, he was the guy that was like the 6.02 times 10 to the 23rd. He didn't discover that number, but the number was named after him. Okay, so we're going to talk about basically with him moles. So his law says that equal volumes of gases at the same temperature and pressure contain equal number of molecules, and that goes to the idea of the mole. So 1 mole of hydrogen gas equals, now this is liters. So we talked about this a little bit before. It equals 22.4 liters. So like if we were going back to the mole flow chart, remember how there were like grams and there was volume. I'm pretty sure we talked about volume. There was molecules over here and then atoms. And you kind of had to go around and all this. If you remember, it was 1 mole equals 22.4 liters. So that's what we're talking about in here, okay? All right, so that's Avogadro's law. And then comes the ideal gas law. So an ideal gas law is the reduction of all the other gas laws into one equation. And the way that I've kind of structured this chapter is I've taught you all of the other laws relating to this one already. So going from those to this should be pretty simple, and it should actually seem even easier than the other ones did. So if you take a look here, this is the ideal gas law. It's not the one we were talking about before with all of this, even though it looks very similar. Because with this one, what we're saying is variables are changing. So for example, when we use the 1 and the 2's, we're saying that they started here and then they changed to something else. For this section, we're going to say that it's not changing, it's just staying. And basically, I'm going to give you 4 out of the 5 variables, and you just have to plug them in. Now, it can get trickier because here you're going to need to do some conversions and stuff sometimes. But overall, I think it'll be a little bit, it won't be that bad, okay? So first of all, what is N? We talked about this in the beginning of the chapter, and N equals, it's the number of moles. Okay, so that's the N that's in here. Okay. And then R is the other thing that we mentioned a little bit in the beginning. This is where we're going to get in a little bit more depth here. But remember, this has to happen at STP. And R equals these conditions at STP. So it basically means PV over NT. Okay, well, what's the normal pressure? Okay, well, pressure at STP, remember how there's a lot of units? There's ATM, there's millimeters of mercury, and then there's also kilopascals. Well, out of all of these, they all have their own number, right? This is 1, this is 760, and this is 101.3. So for us, we're gonna do the easy one. We're gonna go with 1 ATM. So our pressure is gonna be 1 ATM because it's a 1. Ones are easy to multiply by. All right, but volume. So we just learned something about volume. Remember, volume's liters, right? So what's this magic number that we're always going to use? 22.4. Now, why are we using 22.4? Because remember, N means the number of moles. So if you have 22.4 liters, how many moles are you going to have? Yeah, you're going to have 1, exactly, because 1 mole equals that 22.4, right? And what's your temperature at STP? And remember, you have to use Kelvin, so it has to be 273 Kelvin, all right? So when you divide this problem that we just came up with, when you multiply across, divide, you're going to end up with a number, and this is a constant. It's always going to be 0.0821. And now what unit is it, right? What unit is it? Well, it's all the stuff we just talked about. It's ATM, it's liters, it's mole, it's Kelvin, it's a lot, it's 4. So ATM, liters, and then we have moles times Kelvin. So that's the actual unit for it. It has 4 units that make up this, all right? This number is 0.0821. All right, and that's always going to be that. So for as far as you, this is how we derive it, but what you just need to know is R equals this here, okay? That's the takeaway for right now. Understanding where it comes from is important, especially if you're going into like AP Chem. And it's even more important because 8/21 is Mrs. Blake's birthday, and it's good to know the AP teacher's birthday, right? All right, there you go. Okay, so let's do a problem with this. What is the pressure? All right, so we're looking for P in ATM. Okay, so now they're telling us the ATM here, so that's good. Exerted by a 0.5 mole. All right, mole, what was mole again? Yeah, exactly, it's N. Good. A zero point 0.5 mole sample of nitrogen gas in a 10 liter. Liters means what variable? Good volume. Yep, V. And then a container at 298 Kelvin, which is the temperature. Okay, so what's the equation? PV equals nRT. Now, how do we know that we can use this? Well, we're in this section. Normally, it should also say in here that everything is at STP. And that should be a capital T, right? In here it doesn't, but it should always say that. All right, so let's check this out. The other reason that you know you can't use the other equation, like the P1s and the P2s and everything, because if you look here, there's only one pressure. They didn't give you two pressures. So if you kind of figure that out, that'll help you know which equation to use. Okay. All right. So what is the pressure? So we don't know pressure, so it's P. The volume is 10.0 liters. N is 0.500 moles. R, we know what R is, 0.0821 ATM liters divided by K mole. All right, or it could be mole K, you can switch them around. Now, what's interesting about this is in the problem, it actually told us ATM. And no matter what, this unit doesn't change. So if they said up here, if they said, tell it to me in KPA, you would have to solve this whole problem for ATM, because that's what it is here. And then you'd have to convert it from ATM into kilopascal. So you'd have to do an extra step, okay? Okay, so that's a little bit for later. All right, and then the temperature, it's 298 Kelvin. All right, so what are you going to do to solve this problem? Yeah, exactly. All right, so you're going to divide by 10 on each side, right? Because we want to get P by itself. Good. And then we divide by 10 there. Great, okay. And what cancels out? Let's change the color. Yeah, the 10, 10. All right, now over here, units are going to cancel out, right? So if you look, there's liters right here. And there's also liters up at the top there, so they're going to cancel out. And then you have moles right here, and then moles on the bottom over here, so they're going to cancel out. And then you have Kelvin and Kelvin, so they're going to cancel out. Okay, that leaves you with just ATM. So our answer is going to be an ATM, which is great because that's what we were asked to find, right? All right, and then for this one, you would multiply across the top. So 0.5 times the constant 0.0821 times 298, hit the enter button, and then divide it by your 10, and you should get 1.22 ATM. And it's 3 sig figs because everything above was 3 sig figs. All right, hopefully that helps.